Now let us see how to find the point of intersection of two lines. Let us consider that we have been given the general equations of two lines, that is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Right? Now just to give a brief idea of what this means is, suppose the two lines are like this, right? And we know that each line algebraically is represented by an equation that we know. So to find the point of intersection means we want to find a point that lies on both the lines simultaneously. So algebraically what it means is to solve the two equations simultaneously, and the solution of those simultaneous equations represents the coordinates of the point of intersection. So basically we have to solve the two equations simultaneously. Now there is another method to get the common solution of these two equations, which is really not a different method as such, but it is just known by a name, Cramer's rule, that you might be aware of. So what does Cramer's rule say, or how it is used is, first we calculate a determinant delta given by the coefficients of the variables x and y, right? So if we make a determinant, we will get it as a1 b1 and a2 b2. So that's the value of the determinant. Now how it is evaluated, we are aware, that is a1 b2 minus a2 b1. Okay, so to evaluate this 2 by 2 determinant, which is nothing but just a square arrangement of numbers, we calculate the product of diagonal elements, and from that we subtract the product of the other two elements which are non-diagonal elements, right? That's the way to evaluate the determinant. That is the first determinant, which is delta, right? Now similarly we calculate another determinant called as delta suffix x. Okay, now this is obtained by replacing the coefficients of x in the original determinant by the constant terms of the two equations. Alright, so therefore by doing that, what we get is c1 c2 in the first column, and the second column b1 b2 remains intact as it was in the original determinant. So here we get the expansion as c1 b2 minus c2 b1. Similarly we get delta y by keeping the first column same as the coefficients of x, but now the second column gets replaced with the constant terms c1 c2, and hence this evaluation is a1 c2 minus a2 c1. And finally Cramer's rule says that x is nothing but delta x divided by delta, and y is nothing but delta y divided by delta. So this gives us the solution of the two given simultaneous equations. Of course it is important that the value of delta cannot be 0, because if it is 0 then it can't be used as a divisor to find out x and y. And there is another way of looking at it, that means if the delta is 0, that means a1 b2 minus a2 b1 is 0, then what does it actually mean is, let us see here, if a1 b2 minus a2 b1 equal to 0, then that means a1 b2 is equal to a2 b1, hence that means a1 upon b1 is equal to a2 upon b2, and that means minus a1 upon b1 is equal to minus a2 upon b2. But we know that what is minus a1 upon b1, that is m1, which is the slope of first line, and that turns out to be equal to slope of the second line. So it means if the slopes of two lines are equal, that means they are the parallel lines, and if they are parallel lines, obviously there cannot be any point of intersection. So therefore you see how Cramer's rule expectedly fails if the two lines are parallel, and hence we can't use the Cramer's rule in that case, right? So let's practice one example on finding out the point of intersection. Now Cramer's rule is often the simpler way, that is because you have to just calculate the determinants and divide it, so that while solving the equation simultaneously we have to think a little bit more as to which variable is easy to eliminate and so on. So let us go ahead with the Cramer's rule. First let us find out delta, that is 5 7 2 and minus 3. So that gives us 5 into minus 3 is minus 15, minus 7 into 2 is minus 14, which is minus 29. Okay, and of course that is not equal to 0, so that means the lines definitely intersect. Now delta x is obtained by replacing the first column by constants and the second column remains the same. That gives us minus 9, minus 49, so that is minus 58. And lastly delta y is, first column is same now but second column gets replaced. That gives us 35 minus 6, that is 29. Now at the end we have x is delta x upon delta, which turns out to be minus 58 upon minus 29, giving us 2, and y is delta y upon delta, that is 29 upon minus 29, which turns out to be minus 1. So therefore point of intersection is 2, minus 1, which is the answer. It's important to note that to use the Cramer's rule, we must have both the constant terms on one side of the equations and the x and y terms must be on the other side.